Hello students, in this video we will look at hypothesis test involving two samples. So we would be comparing the perceived or assumed population average from one question to that of a second question. So we're going to take a look at question 6 and question 9. So of course question 6, how often have you experienced academic struggles as a student versus do you agree that it's appropriate for instructors to discuss your course progress with each other? So these are Likert scale questions. We've coded them as numbers, 5 representing either strongly agree or always, and lower values representing either strongly disagree or rarely or never. So this is a special type of an hypothesis test. It's called a two-tailed t-test. What we're going to do is look at question 6 and question 9 first of all. The average in question 6, 2.79, has a standard deviation of 1.193. Question 9 has a much higher average, basically meaning that on the average response for question 9 was somewhere between agree and strongly agree. It has a standard deviation of 0.831 and a sample size of 106. So this is a test that we haven't done in statistics in the BA DM 111 course, but it's a nice little test. Once again, if you copy the key data from the questions into the yellow cells here, we have the sample average 2.79, standard deviation 1.193, 106 sample size, and the same thing for sample 2. And it does not matter which one you have as sample 1 or sample 2, but just be consistent in listing out the key values from there. The critical value is something that's going to be automatically calculated for you based on input values in the yellow cells, as well as other things we need. Now we can look at the hypotheses. The null hypotheses is basically listing that there is the best way to write that is no difference between population 1 and population 2. And you know, if we were in the stats class, we'd actually use symbols for this, but this is sufficient. The alternate hypotheses would say that there is, well, I'll just go yes, there is a difference between population 1 and population 2. So that's the null and alternate hypotheses. We are always assuming it's a two-tailed test. It's just easier that way. And these values over here, these are going to be automatically populated or calculated based on the input values you have in yellow. We don't have to worry about what the pooled variance means, but this critical value, it has degrees of freedom, it has our value of significance. The test, so remember that the critical value, this is the T alpha value. And basically at this point it becomes quite similar to a one-tailed, well, I mean not a one-tailed, but a hypothesis test comparing the sample average to one population average. So we have a T alpha value. This is our calculated or test statistic value. That equals negative 9.36. The critical value is 1.971. When we compare the test statistic to the critical value, we always compare positive values. Just makes it easier. So 9.36, much greater than 1.971, so leads us with this decision here to reject the null hypotheses. And you should note with this and with the other tests that these decisions here, let me color them a different color, these are going to be automatically generated based on the difference between your test statistic and your critical value. So I've made it super easy to analyze these hypothesis tests. So we're clearly rejecting the null hypotheses. Basically this one has been rejected. We are left with this hypothesis. which basically says that there is a difference, a statistical significant difference between the values in population 1 and the values in population 2. We can compare or determine a p-value, which will automatically be calculated. We compare that p-value to the level of alpha. Alpha is always assumed to be 5%. It's much smaller than 5%, so of course, based on this decision rule, we would reject it because the p-value, a really small number, is less than this threshold value of 5%. So two decision rules, but always the same decision. We are rejecting the null hypotheses, which means that there is a difference between the values in population 1 and the values in population 2. Your task is to go into the survey and, based on some of the findings that you have received or that you feel strongly about from your focus groups, interviews, personal stories, preliminary results from the survey, you pick a couple questions. And if you want to do this type of test, you look at two that are going to, that are significant or that are key in your findings, and you determine if they are actually, if there's an actual significant difference between them. So we can do that with any of these questions listed out, question 19 versus 20, question 18 versus 19, question 18 versus 22. There's many, many possibilities with this type of question. So that is our hypothesis test for two populations and two averages.